Hello everyone, it's me, Mamian, once again, and welcome back to my channel. If you are new in my channel, please do subscribe and hit the notification bell if you want to be notified on my next video. So today is another day, and so we will be discussing new topic, and that is under statistical analysis and software application, the data collection in statistics. So without further ado, let us jump into new learning. So first up, we have the definition of data collection. So when we say data collection, this is a systematic process of gathering observation or measurement. So from the word itself, systematic process, meaning data collection follows set of procedures. So whether you are performing research for business, governmental, or academic purposes, data collection allows you to gain first-hand knowledge and original insight into your research problem. So you might ask yourself, what is the importance or why do we have to study data collection? Okay, so what is the importance of data collection in statistics? So data collection is very important in statistics since it gives us the raw data needed for our research, for our analysis and decision making, and it serves as the basis for creating meaningful insights, drawing conclusion, and making evidence-based decision for individuals, companies, and organization. So here is an overview of the presentation flow. So as you can see, it's quite long discussion. So we will be dividing this into two parts. So part one will be the purpose of data collection, types of data, sources of data, sampling techniques, and the data collection methods. While the second part would be data collection process, data collection tools, ethical considerations, challenges in data collection, and best practices in data collection. Okay, so let us know what is the purpose of having this data collection in our research or in statistics. So the main reason of this is that data collection is to gather information in a measured and systematic manner. So of course, this is to ensure accuracy and facilitate data analysis. Another one is that it establishes objectives in our research and it provides insight for decision making. So, since the data collected is meant to provide content for data analysis, the information that is gathered must be of the highest quality for it to be of value. Okay. Next, we have the types of data. So we have the categorical data, the numerical data. So we have two types of data. So when we say categorical, these are data that are categorized mostly words and they are not quantified. Data that are not able to be quantified. So more on coding, thematic, semi-thematic, and then we have numerical data from the word itself, numeric. So those data that can be quantified. So we have two two subcategory for numerical data. We have discrete and continuous. So when we say discrete data, those data that are counted and it has a gap in the number line, or data that are counted as a whole. Like example, the number of COVID-19 patients admitted in the year 2022. And then for continuous data, these are data that are measured. Example, your height, your weight, or the volume of water in a pool. So those are continuous data. Next, we have the sources of data. We have two primary sources and the secondary sources. So for primary sources, these are the first-hand information. So they represent original thinking, reports on discoveries or events, or they can share new information. All right, and the data collectors documented the data themselves. Right. So we have an example, surveys, interviews, and observations. Now, for the secondary sources, so the data documented by the secondary source, so the data collectors had the data documented by other sources. or the creator's argument. So they often involve generalization, synthesis, interpretation, commentary, or evaluation in an attempt to convince the reader of the data documented by the secondary source. Yeah, so we have the examples of secondary sources, the published sources, government data, online database are some of the examples of secondary sources. But there are a lot more secondary sources, so you can search that one online. Okay, second to the last topic will be the sampling technique. So I have discussed here, or I have included here the four most used or commonly used sampling technique. So first up, we have simple random sampling. So in a simple random sampling, every member of the population has an equal chance of being selected, and your sampling frame should include the whole population. So sometimes the simple random sampling is called fishbowl sampling. So wherein you're going to right every, say for example, you have an employee, or uh, example for me, I have a student, so I have 100 students, and so I wanted to choose 50 sample only. And so what I did is I assign number per student. All my 100 students, I assign number 1 to 100. All right, and then I put it in a fishbowl, and I randomly selected 50 out of 100. So that is simple random. Next is the systematic sampling. So this is similar to simple random sampling, but it is usually slightly easier to conduct. So this type of sampling technique follows a certain interval. So every member of the population is listed with a number, but instead of randomly generating numbers, individuals are chosen at regular intervals. So if you use this technique, it is important to make sure that there is no hidden pattern in the list that might screw the sample. So example class, I have a students, 50 students in my classroom, and we have 5 chairs per row. So if I say every student, I mean every fifth in the row, every fifth student in a row will be my respondent. So I follow interval, which is the fifth student in the row will be selected as my respondents. All right, so that is systematic. Now we have the stratified random sampling. So stratified random sampling involves dividing the population into subpopulation that may differ in important ways. It allows you draw more precise conclusion by ensuring that every subgroup is properly presented in the sample. So to use this sampling method, you divide the population into subgroups called strata. So in stratified random sampling, all the stratas have equally um, have the chance to represent their strata. Okay, another one is, the last one will be the cluster sampling. So it also involves dividing the population into strata, but each strata should have similar characteristic to the whole sample. So instead of sampling individuals from each subgroup, you randomly select entire subgroup. So example, the company has offices in 10 cities across the country, and so you cannot go there because it's too far. So you decided to use the first company here in the Philippines to be the representative of the whole population. So that is cluster. Only the selected strata will be the representative or the respondents, while on stratified sampling, all the stratas will be able to give or provide a representation of their strata. So that would be all for today, and I'll see you on the next part. Bye bye, everyone.